Hello and welcome to CodeChef. Today we are diving into one of the most fundamental and important data structures in programming, arrays. Whether you're building a simple calculator or a complex game, arrays are everywhere. They're the building blocks that help us organize and manage data efficiently. Before we begin, make sure you're ready to jump onto the CodeChef compiler and try out the examples we'll be discussing today. The link is in the description below. So let's get started.
Arrays. So what exactly is an array? Imagine you're a teacher and you need to store the grades of 50 students. You could create 50 different variables, grade 1, grade 2, grade 3 and so on. But that would be a nightmare to manage, right? An array lets you store multiple items of the same data type in a single variable. This is where arrays come to the rescue. Think of an array like a row of mailboxes in an apartment building. Each mailbox has a number, we call this an index. And each can hold a letter, or in our case, data. Just like that, you can quickly find apartment number 5 without checking all the others. You can directly access any element in any array. Arrays have some special properties that make them incredibly useful. Linear structure. Elements are arranged sequentially one after the another. Contiguous memory. Elements are stored right next to each other in memory, making access super fast. And direct access. You can jump to an element instantly using its index. Today we'll explore how to create arrays, access and change elements, insert and delete elements, merge arrays and work with string arrays. These are the fundamental building blocks you need to master. Creating arrays. In C, you declare an array by specifying the data type, a name and its size. Here's how. For example, int number 5. This creates an array called numbers that can hold 5 integers. Right now, it contains garbage values like having 5 empty mailboxes. You can also initialize the array with values right when you create it. For example, int numbers 5 is equal to 1, 2, 3, 4 and 5. What exactly is happening here is integer, the data type, numbers, the name of the array, 5, the array can hold 5 elements, that is the actual values stored at positions 0, 1, 2, 3 and 4. Remember, array indexing starts at 0, so the number 0 is 1. So at position 0, we have value 1 and at position 1, we have value 2 and so on. For character arrays, car alphabet 5, A, B, C, D, E. This works the same way, but it stores characters instead of numbers. Accessing and changing elements. One of the best things about arrays is direct access. You can read or change any element using its index in big O of 1 time. That's the constant time, which is super fast. Accessing elements. Here we have int numbers 5 with the values 10, 20, 30, 40 and 50. Printf %d number 0 prints 10 because at position 0 we have value 10 and printf %d numbers 2 at position 2 we have 30, so it prints 30. Changing elements. Integer power of 2 with 5 values 2, 4, 8, 16 and 32. Power of 2 at position 1 is equal to 100. So we have changed 4 to 100. This is position 0 and this is position 1. We have asked to change at position 1 to 100. So 4 is changed to 100. What happened here exactly? The original array 2, 4, 8, 16 and 32, we changed the element at index 1 which is 4 to 100. So our new array is 2, 100, 8, 16 and 32, replacing the 4 over here. Why is this so fast? Because arrays store elements in contiguous memory location. The computer knows exactly where each element is stored. If the array starts at memory address 1000 and each integer takes 4 bytes, then at number 0 is at address 1000 and numbers 1 is at address 1004 and numbers 2 is at address 1008. The computer can calculate any element's location instantly using the formula base underscore address plus index into element underscore size. This is why accessing or changing an element is big O of 1. It doesn't matter if the array has 10 elements or 10 million elements. Insertion in an array. What if you want to insert a new element into the middle of an array? Let's say we have 2, 4, 6, 8, 10. We want to insert 5 at position 2 between 4 and 6. The process would be to determine the position where we want to insert at index 2. We shift the elements, move everything from index 2 onwards one position to the right, and we insert the new element, which is place 5 at index 2, and we update the size. So our array now has 6 elements instead of 5. Now let's visualize this step by step. This was the original array where we had 2, 4, 6, 8 and 10. Now we shift 10 one position to the right, 8 adjacent to 10, 6 next to 8, and we insert 5 between 4 and 6. Here's the problem. When you insert an element, you have to shift all elements after it. In the worst case, inserting at the beginning, you would have to shift every single element. Time complexity. This is why insertion in the middle of arrays can be slow for data sets. If you need to insert many elements frequently, other data structures like linked lists might be better. Deletion from an array. Deletion works similarly to insertion, but in reverse. Let's say we have this array of 2, 4, 6, 8 and 10. We want to delete the element at position 2, the number 6. The process to delete 6 from that position is we want to delete index 2 and then we move everything after index 2 one position to the left. And we update the size of an array. Our array now has 4 elements instead of 5. Now let's look at this by visualizing. Now we want to remove this. We move 8 to the left, 10 to the left, and this means the size of the array has reduced. We ignore the last position. Again, in the worst case, deleting the first element, you have to shift all the remaining elements to the left. Merging two arrays. Sometimes you need to combine two arrays into one. This is called merging. Let's say we have two arrays like this, 1, 3, 5 and 2, 4, 6. To merge them, we create a new array big enough to hold all elements with size of 6. We copy elements from array 1 to the new array. Copy elements from array 2 after array 1's elements. So, the two arrays which we had of 1, 3, 5, 2, 4, 6 becomes 1, 3, 5, 2, 4, 6 in one single array. The process was we started with the empty merged array and then we copied from the array 1 which is 1, 3, 5 and then the rest of the elements from the array 2. This operation is big O of n plus n where n and m are the sizes of the two arrays because we have to copy every element once. Note that this is a simple merge where we just concatenate the array. If you want a sorted merge, combining two sorted arrays with one sorted array, that requires a different algorithm. String arrays. Now, strings in C are a bit special. A string is actually an array of characters. To declare a single string, car 6 is equal to Tesla. Tesla has only 5 letters. Then why is the size 6? Because C adds a special character, null terminator at the end to mark where the string ends. So internally it looks like T, E, S, L, A, null terminator. But what if you want an array of strings like a list of car brands? Car character 4, 10 is equal to Tesla, Honda, Toyota, Cruise. Here, think of this as a 2D grid or a table. At card 0, we have Tesla, which is T, E, S, L, A and null terminator. At car 1, we have Honda, car 2, Toyota and car 3, Cruise. To access a specific string, print F %s, car 0, which prints Tesla because at car 0 we had Tesla, and printf %s cars 2 prints Toyota. To access a specific character with a string, we write printf %c. We use printf %c cars at 0, position 0, it prints T. because at position 0, at car 0 we have Tesla, and at position 0 of car 0 we have T. Print F percentile C cars 1 position 1 prints O because second character of Honda. The first index tells you which string and the second index tells you which character in that string. Now let's summarize what we've learned. Creating arrays. Declare with size and optionally initialize with values. Accessing and changing elements uses indices for direct big O of 1 access to an element, and inserting elements, it shifts elements right to make space big O of n operation because we might need to shift all elements, and deleting elements shifts elements left to fill gaps. The time complexity is big O of n operation for the same reason, and merging arrays, which copies all elements from both arrays into new one. The time complexity is big O of n plus m operation, and string arrays uses 2D character arrays where first index selects the second index selects the character.
Amazing work today, guys. You've mastered the fundamental operations that form the foundation of working with arrays. Now head over to the CodeChef compiler and practice these operations yourself. Keep coding, keep practicing, and I'll see you in the next one.